Okay, so we were integrating by pattern, which you can do if there's a license to integrate. So then when we got to this yesterday, this is when we were saying that sometimes it's not there. Even though yesterday we could kind of create it, but on this particular problem we started, we couldn't do that. So we had identified the inner function as 2x minus 1. The derivative of that, or what would be our license to integrate, would be 2. So, like we did yesterday on some of the later problems, we tried to create the license to integrate. Well, you have to take out that extra piece, which is an x, and that's where we ran into a problem. Because you can't take an x out and put it in front of an integral. You can only take constants out and put it in front of an integral. So that's why it said, is g prime attainable by multiplying the integrand by a constant? No, it's not, because I can't get rid of the x that's inside. So, no. It's not possible. So in this case, I have to use another method to find the antiderivative, and this is called u substitution, which I want you to think about. We did u substitution with chain rule. Do you remember? Now, I think now we don't do it anymore because y'all are like, hey, we can just blob it and we know the chain rule and it's no big deal. But when we first started, especially if there are multiple pieces inside the pieces inside the pieces, we would call one of them u and we would do that. Sometimes we would call one w and we would do chain rule that way. Well, this is u substitution for integrals. Okay, so the first thing you're going to do is let the inner function be u. So in this case, that would be my 2x minus 1. And then I'm going to find du and solve the equation for dx. So that means take the derivative. So if I do du, take the derivative of this side, that would be 2 dx. And then solve for dx. So divide by 2. So I have now dx equals, that cancels here, 1/2 du. Because of du over 2, I just wrote that as 1/2. Is everybody okay? So basically what I just did was I took the derivative in terms of u, and because I couldn't take the derivative in terms of u, I had to write a dx on this side. Yes? Everybody alright? Okay. So now, find an expression for x in terms of u. So just using this that I just created up here, I'm just going to solve it for x. Okay? So now, I'm going to rewrite the entire integrand as a polynomial or polynomial type of function in terms of u instead of x. And then we're going to antidifferentiate it. So here was the original. I'm going to rewrite it real fast. Now we're going to change everything and put it in terms of u. Well, I just solved for x down here. And x equals u plus 1 over 2. So that means this x has to be changed. I'll write the integrals down here. This x has to be changed to u plus 1 over 2. Because right down here, that's what x equals, u plus 1 over 2. So I just changed that piece. Yes? Everybody good? This piece in the middle was the original u. So I'm going to write it as u cubed. That's this piece. And dx, I solved right here, is 1/2 du. Everybody okay? So we just substituted. Now let's simplify. I have some constants I can pull out. I can pull out a 1/2 But I technically have a 1/2 right here also, so I can pull that out. So out in the front, I'm going to pull out a 1/4. Very good? That leaves me a u plus 1, a u cubed, and a du. Now, because it's a lot easier to integrate a polynomial, just like it's a lot easier to find a derivative of a polynomial, let's go ahead and distribute the u cubed into the u plus 1. Now we can just take the antiderivative.
Does it say? Wait, what?
Where'd I lose you?
Hold on.
And now all we have to do is just put back our u. I am going to go ahead and distribute the 1/4 back into each piece just to make it a more polynomial-ish. So I'll do this in 2 steps. And then remember at the very beginning what u was. It was 2x minus 1. Do up to the c? No, because we're just going to plug the 2x minus 1 right back in. And that's it.
Oh, that's it.
That's all. It's really not that bad.
Yeah, okay.
It's really not.
Yeah. I'm 10 feet tall.
Okay, so let's do another one. Okay, but if you'll just read as you go right now, it's explaining to you exactly what you're doing. So, just go step by step. I'm going to let you try, and then I'll go through it. So I'm going to give you a second. Just try, start the steps.
Hold up. We went from an easy one to a...
Not.
How do I figure that out?
Just go step by step. Let u be the inner function. Just go step by step. It is not any harder.
Mom. Everything's going to shoot, man. I run into a problem. Step 2. Let's go ahead and... I was going to ask, on that first example, how do we get du equals 2dx so that I can figure out...
You just take the derivative of both sides.
What do you take this?
Take the derivative of u, which would be du, and you took the derivative of 2x minus 1.
Okay.
Just took the derivative of both sides. That's all I did. You're going to do the same thing. Take the derivative of both sides.
So u just becomes du, and it's du. Okay, I understand. Although I'm not sure how I'm doing. What? Du is the derivative of u. U is this whole thing.
For the whole thing?
Yeah. But all you have to write is du equals, and then you gotta find the derivative times dx or whatever. How do I find the derivative? Mom. I should have died in the whole class. That's who I should have been. But you know what? It's fucking fake, so I couldn't die. Special district county municipal. Wait, how the crap did you? What?
Let u equal the inner function.
Oh.
The only function inside of anything else is x plus 4.
I thought you meant like the entire thing. Oops. Sorry.
See? Over here, 2x minus 1 was the only piece inside the function. These are composite functions.
I don't know what I did.
There's something that's inside something else. Alright, the derivative of x plus 4. What's the derivative of x?
1.
Right? It's not in terms of u, so I have to write 1 dx.
So it's just dx equals
So
du.
dx equals du.
So you would just do wherever you plug in u for x, it's just u. It's not gonna be-
Well, now, find an expression for x in terms of u. Here was what we plugged in. U equals x plus 4. Solve it for x.
X equals u minus 4.
Yes. Now we need to rewrite the entire integrand in terms of u. Now this is the only part of this one that gets a little bit harder.
No, please. What?
Before I rewrite it in terms of u, I'm going to rewrite it. Why would I do that? Yeah, because I've got the square root thing on the bottom, and I would much prefer it not be there. So I can first rewrite this as 2x plus 1. Instead of divided by, I'll do times x plus 4 to the negative 1/2. Now I'm going to rewrite the whole thing in terms of u. Okay, so the 2x plus 1 piece, that's going to be 2. I solved down here, x equals u minus 4, so that's this. Is everybody okay? Then x plus 4, that's my original u. See right here?
So you
X
just
plus
write
4
u?
is my original u, so I can put u to the negative 1/2. Yes. And then dx is equal to du, right here. Dx equals du. 1 dx, 1 du, they're equal, so I can just change dx to du. Okay, now I'm going to before I actually integrate, I'm going to simplify this because I can distribute this to both of those pieces. So now I have 2u minus 8 plus 1, so I'm just going to put minus 7 if everybody's okay. U to the negative 1/2 du. integrate a polynomial. So I'm going to distribute when you multiply, you add exponents. So u to the 1 times u to the negative 1/2 is u to the positive 1/2.
Oh, yeah.
Now I can take the integer. I'm going to write this step out, and then I'll go back and change, switch, flip it. Everybody okay?
Yeah.
So I added 1, divided by what I got. Now I'm going to keep switch flips. That's going to make this 4/3.
Wait, 4/3 u to the 3/10?
You have to multiply. Keep switch flip. So that'd be 2 times 2 over 3. Yes?
3, okay.
So it's 4/3.
So you would have to multiply your u to the negative 1/2 out before you take the integral.
It's a lot easier if you do that. We don't know how to integrate by parts. Like, and now last step is just plug u back in.
Still getting this on my own.
Not so bad. Okay, so now if you look down at the next example, only difference is now it's no longer an indefinite integral because I actually have boundaries. It says to go between 0 and 4. So the process is still the same. This is still by u substitution. I'm going to do all of the steps above. Let u be the inner function. Take the derivative in terms of u on both sides. Find an expression for x and u. Plug it back in. Then I'm going to have to plug in my 0 and my 4. So let me just warn you, write small. I don't think this is enough space down here. It might be, but. So start. I'll give you a head start.
Some nice numbers you got in there. Because I can't do this one. So I'm just going to put it. What? What do you do?
Okay, how are you finding?
How to find dx?
Answers to
Okay, do you get why it's du to dx?
Shut the hell up.
Because you take the derivative of both sides, and the derivative of
No.
du is just 1 du.
Okay.
And the derivative of this side is 2 dx. dx, right, so I divided by 2. Yeah.
Alright. I figured out what u equals. I figured out the dx equals like 1/2 du or whatever, and I figured out the find an expression for x in terms of u.
Uh-huh.
Now what the heck do I do, because there's numbers in this one, so that makes it different.
No, it doesn't.
So I just plug it in like that?
Yeah, just plug it in.
Really?
Yeah.
Then what happens whenever you...
Nothing happens until you actually take the antiderivative. And then
Okay,
you do
so-
exactly what we've always done.
Until then it just stays...
After you take the antiderivative, then we plug everything back in. Then you worry about the numbers. Hey, I know y'all could care less about calculus, but go play games somewhere else. Find somewhere else to go during the day and play games. Y'all would be in just boatloads of trouble if I all of a sudden just decided I was actually going to fail people. If I was like, you know what, I don't even care anymore. Your grades are what they are. And I could do that. I could do that. I won't, but I could.
Oh, okay, hold on. You know way faster than I can catch up to.
After that.
Take the antiderivative.
Holy crap.
And then after that, you project.
Yes.
You're going a little faster than me.
You're supposed to be doing it on your own. I'm doing it on my own. You do it on your own. Look up.
I
See
know,
if you
I'm
need help.
trying, but I'm a little bit behind.
But your interval doesn't have numbers in it, so you don't put the numbers back in until you find out.
That's right. That's right.
How is that one? Because you have a minus 1 over 4. Which that doesn't go away, does it?
I distributed this week. Is that what you're talking about?
No, in the original u minus 1 over 2, when you take that out, it's the 1/2 you have to take.
I took both 1/2s out. I took this 1/2 and this 1/2.
Oh,
So then, after you find the antiderivative, you just plug in the numbers?
Yep.
Okay, hold on. How'd you get the... Okay. Let's see. Okay.
so you don't have to add the C, right?
No, because we've got numbers. So that's going to go away anyway.
Hold on. Wait, where'd you... Oh, that was after you took the antiderivative. Okay. Took this off for that. Oh, so it was a 1/4. That's what I forgot.
This really have to do for it.
Yeah, exactly.
All right. So you just, after you set it up, you just plug in the 0 on one of it and then plug in the 4 on the other?
And you won't have to plug in the 0, because when you get to
Oh.
here, you realize they're both multiplied by that.
So the 0 will be
Oh yeah,
0.
you will have to, because
Wait,
it's
why?
1. Because it's 2 times 0 is 0 plus 1, so you will have to plug it in. Dang.
Minus. I like.
But at least it's 1.
Can we use our calculator for that one?
It says check your results on your graphic.
That's some ugly math. I don't want.
Yeah, I don't wanna.
It's pretty nasty.
Yeah, I don't want to do that without a calculator. That's some nasty math.
What you plug it in, see if
How do
you
you-
raise a number or top.
It's not gonna equal 12, Jackson.
What is the 5 halves?
Crap.
Bottom of the crack. Where's the
Wait,
5
so-
Oh my goodness.
5 or
It's not bad because they're both perfect squares. So it should be easy. That part should be easy.
okay, hold on. I can't see exactly what you wrote there. Did you do 1/10? Is that the 4 plugged in or the 0?
This is the 4. And this is the 0. Because what happens when I put 0 right here? It's just 1.
Yeah, just because.
And the square root of 1 cubed is just 1. The square root of 1 to the 5th is just 1.
So it's just the 1/10 minus the
So
1/6.
it's just the 1/10 and the 1/6.
Now what about the Mike deal was the first part? Does that say 4 to the 5th or like square root of 4 to the 5th?
I
can't read lower that number.
have square root of 9 to the 5th.
Okay. So
Plus, minus.
Distributed money. This is all I get. I have 2 fingers.
you like it? Well, unless I just did it completely wrong.
Which I'm sure, okay, has a 2 in it.
Whoa, that's a big answer. That was not at all what I did. Wait.
that makes it 1192.
Yes.
Still divisible by 2.
Oh, I got the answer right.
It's 12, right?
No, it's not. It's 19.5333.
Um,
You're off by 7.3333. I did it, God.
Let's not fit to ourselves here.
What?
Let's not lie to ourselves.
But I'm doing good right now.
Just wait and for the next complication. For the next evolution of this.
It already evolved enough to where I feel like it's hard.
It's a lot to simplify.
What do you get correct answer?
I would hope they wouldn't ask one that hard, but I can't promise you they won't.
I went to 596 and 30.
Wait, what'd you
But
get?
that's divisible by 2, because
Yeah.
that's where I was too, is 596 divided by 30, and then, so then I divided by 2 again, and that works, but then I thought, so it should be divided by 6, and that doesn't work, so I'm sure. But it probably doesn't work, because I did it wrong.
Okay, wait, 30, y'all got that? 590.
So it's divided by 4.
293 divided by 15.
1192 and 60 both divided by 4.
Wait, what? I got 293. And whenever I checked in the calculator, that's what it got to. See, look. When you just plug in the door.
I don't know, it's that simplified.
And
That's
then
right,
It's 19. Wait, what is that?
1192
1192 over
divided
60, but it simplifies.
I think it simplifies down to
No, that's not
Something.
right.
like down to,
Let's see.
what is that?
Where are you plugging
It
it in from?
simplifies to 298 over 15.
Ah,
For
no,
both of
I'm
them.
telling you that's not right. Miss Bohannon,
Yeah.
where are you plugging that in, or whenever you're checking it with your calculator, you wouldn't get the same answer if you got 298 over 15.
It's,
Dude,
yeah, it's 298 over 15. Yeah, you would.
Okay,
It's the
hold
same.
on. I put in.
This is,
But I
this
put
is
that
298.
correct.
This is
I
298
put
over
this whole thing in
15.
my calculator. It got
Divide by 4.
293 over 15. That's
298.
no.
no, plug it in again.
Plug
Plug this in. Plug this in.
A lot of work.
I thought you said your phone was charging your car.
Hold on, let me.
That ain't 12, that's for sure.
Yeah, you dang right it ain't.
I can't think what last year was about.
No, it's 19.8667. That was close.
Yeah.
Okay, whatever.
Close enough.
Oh, we still have
You said you got it right.
I thought I did. No, I didn't.
Didn't you say Frank said nothing on it?
Yeah, and then I said I was lying to myself also. So,
You got something on you, boy.
it's not anything wrong with me.
Everything.
Honestly, if we're being honest here, we're being honest here. Yeah, I feel like this. Not with my couple.
What do you say?
Everything's super predictable.
Should I get like
Super
You nearly impregnated her when you were drunk?
Every time something happens,
Yeah, honestly, I'm not even surprised.
right about like one kid just dropped her
I was
ball.
like, thinking about that the other day, I was like,
It's the same with like sickness.
Imagine what you would
Like if I have like a
Kill me.
kid, I'm like it's
Cut off my
appendicitis. If someone gets to a hospital,
Just
it's
kill
that.
the baby.
Probably, honestly.
Also, flash, there's running fever, I just know.
probably take care of it.
Oh, what the hell does that say?
They still have hypothermia.
Do I smell pee?
Like,
Hey,
you always know.
you go to ROTC and meet from.
Hold on, I'm getting y'all's too. I don't.
Yeah.
Oh, I feel just a slight bit nervous, I'm just confusing.
I would go or a teacher because I didn't.
She's like, this is her right side.
She just told me about it already.
About what?
ROTC.
No, not that. Like, I couldn't think of my mom would have. She'd kill me. I wouldn't be
I
able to
know,
go.
you should just tell her about the
She's saying
podcast.
she's
No.
Say, Mom, I'm paying for half of my college. It's a scholarship. And then that will make her happy. And then say, and I'll be there for city government. So,
That's all.
it's like,
Just
yeah.
that one.
These are like what?
Place for everything except for religion.
Yeah.
Place for every tuition.
I really started looking at how much money
Appreciate it.
Let's see if I can figure out how to do this one.
How I told you.
Well, I mean, what do you get? Basically, your age.
Wait, what? I'm gonna need to use my phone.
Too bad you gotta shave your head.
Oh, what'd you say?
You gotta shave your head. You could just get a cut of hair and eat.
You have 6 options.
Cancel.
Yeah.
Man,
But if Dylan could shave his head, you'd shave it.
No, honestly, never.
But they're all very specialized.
Oh, yeah.
That's like the most information.
That's
No.
good.
No.
Home to get up to school early and drive over there and drive back. It's not how much hours. I really showered.
yeah, I mean, if it's happening, we're not playing.
Okay, so these, I think it might have some of both kinds on here, maybe the kinds that you can do with, yeah, because I'm looking at number 5, and number 5 you could definitely do with pattern recognition. Because I could remove the 5 and put a 2 in, and then I'm good. Actually, it has to be a -2, but you could do that. That one with pattern recognition. That might be the only that might be the only one. Oh no, you could do one. You could do one with pattern recognition.
Wait, what?
Because the derivative of the inside piece would be 4x to the 3rd. So it's only the 4 that I have an issue with. So you could do that one.
So what would you do? Put a 4 by it and then put a 1/4 on the outside? Okay.
And you could do, I think you could do 2 with pattern recognition because the derivative of the inside piece would be -4x. And I have the x, I just don't have the -4. Actually, you could do almost all of these with pattern recognition.
That sounds great.
Yeah,
That makes life easy.
it does, it makes it easier. It's not until you get to number 7 and 8 that you have to do your substitution.
What?
Okay, why is it
You were sitting up there too, so you could.
That is stupid.
so stupid?
That is stupid, but you can do it by pattern recognition and not by. So you can create a license to integrate. I wish I knew what the real word for that is. I totally made that up.
Can you imagine eating a bowl of cereal?
License to integrate. I'm sure that's a real thing. I'm sure.
You made that up?
Can you
Well,
imagine eating a bowl of
I've heard
cereal?
somebody say it, but it's not real. That's like not a mathematical thing to say.
Can you imagine looking at all that sand
Don't go
in
tell
your
me
mouth?
that.
Oh, then you just take that.
My teacher said you have to have a license
I
to
got it.
integrate.